Welcome this morning to Global Distribution Presents Around the Kitchen Table. Unfortunately, I'm not around my kitchen table. I'm actually in my home office this morning. And with us today, we have Qumulo. So just to introduce you to the people on the session this morning, there's my good self. I'm currently a senior product specialist at Global Distribution. Iain, Malins, who will be taking us through the outlining what Qumulo is and some of its unique features. And Iain Marcroft, who's the European SE sales engineer, and he'll be taking us through a live demonstration of how easy it is to set Qumulo up in the cloud. But first, I thought I'd just give you a quick overview of Global Distribution. So it's a UK-based company based in Cambridge, and we're a specialist distributor for storage and production equipment for the media and entertainment industry. We've been doing that for many years now. We have around 30 staff around the world, selling into over 70 countries with actually it's 3,000 resellers. And we carry around about 30 brands. If I can have the next slide. Just to give you an idea of the range of products and brands that we support. But today it's all about Qumulo. And I'll pass over to Iain, who will now take us through the attributes of that file system. Thank you.
Right, thanks Chris, thanks for that. So I'm Iain Malins, I'm the account manager here at Qumulo in the UK. I've been here for about two and a bit years since Qumulo entered into the European market. I've joined with my colleague Iain Marcroft, who's going to do a technical hands-on demonstration of how to configure a Qumulo cluster in the cloud. So it's going to should be interesting for people to watch. So what I wanted to do is quickly go through and talk a bit about, why Qumulo? Why was Qumulo designed and developed? What was the thoughts behind it? So typical timeline here with a graph of showing storage growing, ever growing up to the right, an exponential curve. They reckon over 100 zettabytes in the 2025s. So that's been going on forever. That's nothing new. And the majority of this data that's out there is unstructured file data, and it's basically the data that gets served out to enterprise applications. And the file systems that do that, well known. These are the well-known ones that have been out there for a number of years. In fact, they've been around since about 15 to 25 years when they were first developed. So they're getting quite old in their initial design concepts. Designed before a lot of technology, even before SSDs and things like that. So those sorts of things. So what's actually happened is that whilst all those file systems have been in place, of course, there's been an explosion in new technologies and new facilities and new ways of working. Everything from cloud to big data to IoT to machine learning, and all these things place different demands onto the file systems than they were originally designed for. And they've tried to adapt them, absolutely, but things don't quite work out right if the underlying design isn't correct. So around about 2008, 7, 8 was sort of a tipping point. People said, "Oh, file systems can't keep pace with this growth." And actually, it was a growth of the number of files. If you've got Internet of Things producing hundreds of thousands and millions of files a day for coming back, it just begins to fill file systems up. They just can't handle the sheer volume of the number of files and things like that. So a lot of people went into object stores. And object stores answered the problem, but created 2 or 3 others. Sharing of data, performance, your loss of POSIX interface, all that things. And a lot of enterprise applications just couldn't, would need to be rewritten to do this. So a lot of applications, especially in the video world, which we're talking a lot about today, they're not going to work with objects. They work with files. They've always worked with files and share files between NFS and SMB and be able to have multiple applications talking to the same files. So Qumulo looked at this looked at the problem, and was decided to and was founded in 2012. And they were the founders of Qumulo, were the people who designed and developed OneFS. So they've got a strong background in file system design. And they decided they wanted to design a file system for the 21st century. So this is fundamentally different. It's not building on something else, not like a ZFS with stuff underneath. It's brand new. It's a brand new file system. Started in 2012. First sold in 2015 and has been developed ever since. So the actual system design has changed over the years as well. So it's gone from scale up, which is a traditional 2 head units, a fixed performance, and you just expand the amount of disk on it. That was used to be, typically were based on appliances. Well, they were very good, but what we found was they were limited scale, and you basically built one and it got full, and you then bought another one and another one. You sort of liked your first and hated your 10th. And that was the way of scale up went. Then a scale out came out with the 1FS file system, and that was good. It allowed you to grow in a node type fashion. It was a cluster. You add a node, you grow capacity and performance, and that was really good. But of course, there was other problems around it. You know, difficult to use with small files. If you've got too many files in it, it has a big problem. And it wasn't built to run in the cloud. Just was not built. It's built to go on an appliance. So what Qumulo did is we've designed what we call a new technology to try and address all the issues that we saw and we investigated. And I'll go into a number of them now. So here's some of the sort of the key features that we wanted to hit. So scalability. We wanted to be able to have a file system which scales to billions and billions of files, to grow to petabytes of capacity and deliver a linear growth. So from tens of gigabytes up to hundreds of gigabytes performance. So absolutely, that's what we want to do. We also wanted to build a cluster, a system that could run on-prem and in the cloud. And the way we did that, we made it a software-defined storage technology. So it's not linked into the hardware. We're running user space, so we're not fiddling with the kernel. We're not putting any special hardware in there. So it's very much a hardware agnostic technology, can run on-prem and in the cloud. One of the other things we found, a lot of the customers were complaining about the fact they didn't know what was going on inside the box. So the operational staff couldn't tell what was happening. So we want real time, up to the moment, data analytics coming off the box to be able to see what's happening to the technology. And Iain will be able to demonstrate this later on. When you're in the cloud, of course, automation is key. You can't put something up in the cloud and just manually configure it all the time. You want to be able to write scripts, develop automation and orchestration to get this thing. So a full REST-based API for every single function. In fact, we don't release a new feature unless the REST-based API is released. So you can actually, construct, build, test, monitor everything inside a Qumulo cluster through the REST-based API. And finally, we wanted to change the way support was done. So we put in cloud-based monitoring, so a lot of telemetry from the machine goes up into the cloud for our support engineers to be able to see, for the customers to be able to see what the technology is doing, and be able to give you an enhanced support experience. So just a quick description of how the technology is put together. So as I mentioned, it is a scale-out technology. It's built on a node-type infrastructure, and you see on the right-hand side 4 nodes. Each node has network, CPU, memory, as you would expect, as it's a server, it's an x86 server. It has SSDs and hard disks in each one of them. You need a minimum of 4 to put together to build the cluster, and that gives you a tier of SSDs and a tier of hard disks. Okay, so the way the file system works, it provides a tiering system between the SSDs and the hard disks. All hot writes, if you're writing to the file system, will always land on SSDs to give you really fast random access and sequential throughput. All hot reads get moved off the hard disk layer into the SSDs for reading, and all our metadata sits in SSDs. The data that's striped across the system is striped using erasure coding, so it's all protected across everything. You can read any file from any of the nodes. It looks as a complete cluster. Again, we serve out over NFS and SMB to all the standard protocols to normal clients. The networks can enter anything from 10 gig Ethernet or up to 100 gig Ethernet, depending on the cluster type, and the node type. And that could be because we have an all-flash cluster, so 100 gig Ethernet, or we have archive type nodes, which gives you down to the 10 gig Ethernet. Clients, applications vary from lots of different things. So genetics, transcoding, non-linear editing, corporate file shares, a whole range of file applications we see run on this system. To upgrade the system, you basically add a node or multiple nodes to the system. They're instantaneously added into the system. And the file system, which is one single file system, just grows in capacity and will grow in performance as well. So that data is instantly available. So the file system is bigger instantly. And then we do a rebalancing exercise in the background, which actually spreads the data evenly across all nodes so that they can be accessed and get the performance equal across all the nodes within the infrastructure. Of course, the file system is an enterprise-ready file system, so it would be as you expect. All the high-level enterprise-type features are in the system. We sell it as a subscription. It's bought on a 1, 3, or 5 year basis typically. And what happens is we provide everything in the file system whilst that we've developed, and anything that goes new. So we're not going to give you a la carte and say, well, we've developed this new feature and we're going to charge you X amount of pounds to have it. It's basically available directly out of the box. So we've mentioned the cloud, and the way you deliver the cloud is pretty well exactly the same way as you deliver an on-prem cluster. So here's a cloud cluster. You need to have four nodes. You build 4 nodes, and they could be in AWS, their EC2 instances, in Google Cloud, their GCE instances. So those are the CPU types. You select 4 of those. You attach storage to them, either EBS volumes or persistent disks, depending whether you're in AWS or Google. And those disks can either be all flash or all SSDs, or they can be hybrid, as I mentioned, so SSDs and hard disks. And you basically can build that cluster up in about 2 minutes and provide the interface and work on that. So what I'm going to do now is done enough talking about how we do this. So what I'm going to do is I'm going to introduce Iain Marcroft. He's going to come on and show you how to do this. And I'll just quickly swap onto the slide, which shows the infrastructure that he's going to build for us today.
Yes, thanks very much. Yeah, good morning, everybody. Yeah, so this gives you an example of one of the workflows that we build out in the cloud. Very useful as a demonstration. It'll take typically about 10 minutes to do this, and the beauty of this is we're building it in your VPC, so you've got all the security features you'd expect of being able to run this workflow within that private secured area. So what I'm going to do to start with is build out the cluster. That will consist of 4 nodes, and I'll show you that in the marketplace. Second, then we'll create an editing machine. That'll be a Windows-based machine in this example, where typically we can run whatever application it is that we want this editor to be using, and then we're going to connect into the environment. We'll typically create a share into that environment as well to be able to run our projects on, and we can, as Iain articulated earlier, we can map this over SMB, and we could also map it directly to NFS as well, the same directories and same files. And we'll connect into that environment remotely from a Teradici client. I'll be using today a Teradici software-based client, which is installed on my Mac. But you've also got the option of running these 0 clients, and there are different flavors out there. They're running a Teradici 2 chipset inside. Typically, environments tend to prefer these because they can control who has access to what environment. They'll pre-build these from a single pane of glass manager and program this to connect into a particular machine which has been pre-built in the cloud, and they can send these out to their editors and gain access to it. So what I'll do now is I'll share my environment out in GCP, and I'll show you exactly how we build this out. So just want to get a thumbs up that you can see my screen, my GCP environment.
Yep, yeah, exactly.
Okay, cool. So this is an environment I've already pre-built out, which I'll jump onto in a bit and show you some of the applications that we tend to run in the environment. But what I'll do to start with is build this environment out. The first thing I do is go into the marketplace, and I'm going to do a search for Qumulo in the marketplace and build out a cluster. We can see here we've got 2 options available. So Iain spoke earlier about different node types that we have. We also have different node types in the cloud. So I can build out an all-flash cluster, which has got 10 terabyte nodes, and I can scale that out, however big I want. Or we've got some hybrid nodes here, and the difference between the hybrid nodes, as Iain said, it's a layer of SSD and a layer of hard drive. So we're doing automatic tiering within the nodes themselves so that all our writes go to SSD and our metadata is pinned on SSD and all our hot reads come out of SSD. So I'm going to select the 5 terabyte node type. And this here will give you some examples, what version I'm going to be running, version 3, the version of Ubuntu, which is the underlying operating system that this runs on, and some idea on costs as well that it's going to take to run this environment. So I can give this a name, so something like GPC test would do it, if I hadn't already called it that. And then I'm going to choose a zone I'm going to run this in. So it's important to note this is about the GPU class that you want in a particular environment. So you need to do some research first of all to make sure that the GPU instance you want for your Teradici machine is in the zone that you're building out in. So I'm going to build this out in Europe West 4B. I know already that I've got a couple of options there on GPU class that I can use when I build that machine out. And this is the node instance count. So as Iain said, minimum starting point is 4, but I can build this out as bigger or small as I want. And I can also change the instance types on the fly as well, which gives you some great flexibility in building it slow and small to start with and then scaling it out big and fast as you need it. Here I can choose, how many CPUs and memory I want in each node. So once again, that adds to the performance of each of the nodes. And then the network I want to run it in. I'm running it in my VPC. And if I want to put a public SSH key, I can do. I'm just going to deselect that because I'm not interested in this demo environment of protecting the backend blocks of accidental deletion. And I'm just going to deploy that out. So that's as difficult as it is to build a 4-node cluster out. So typically this will take a couple of minutes to build out. And if we go into our VM instance environment, you'll see it start populating with this new cluster, 4-node cluster in here. So while that's doing that, what I'm going to do now is to jump back to the marketplace and then look for my Teradici client. So we've got a few options here. I'm interested in the graphics version. Yes, the only option they have is a 2016 server instance. I would have thought they would have also had a Windows 10 option, but they don't have. So I think you'd have to build those manually. So I'm going to select the graphics version. Once again, same screen giving me some ideas on costs and what version I'm going to be running of the actual client software itself, and I'm going to launch that out. So deployment name, and then this is what I was talking about with reference to the GPU options available to each zone. So I was on Europe West 4B as my zone, and I run out of quota on that. So I'll choose a different zone. So in here, I've got the option of what GPU instance I've got, how many I can use. In 4A, obviously the only one I can use is a P100. So depending on where you build it will depend on what NVIDIA GPU type you get. Decide on what sort of memory and CPU count you want. This registration code here, if you want to test this out, you can normally get a registration code from Teradici, which allows you to have a period of free license while you're testing out. Boot disk size, networks, etc. It's going to pull out. It's going to create some firewall rules for me to allow my client to connect in over that PC over IP protocol, and I'm just going to deploy that out. So jumping into the VM instance, we'll start to see these all start to build out now. So as far as physically building that out, that's as hard as it gets. So I've got my 4-node cluster here. This is my 4-node Qumulo cluster, and then I've got an editing machine which will start to build out as well. To log into this cluster, what we've got is, as we scroll down here, it assigns a temporary Qumulo password here. So logging into the GUI is admin and that password. And similarly with the actual Teradici client here, you can see it start to build out now. So typically we'd come into here and we'd set the Windows password for it to allow us to create a username and password to log into this environment. So that's basically the build of a 4-node cluster and a single editor in the cloud. Typically you've got other bits of work to do on this around, I want to connect to a client, map a drive, etc. What I'm going to do is show you the environment I'd built out already. So here's one of the other editors that you could see from this environment here. So this is, I've got an editor 2, and then I've got this other editor here. So those two, this is one of those editors. And this one here is running Adobe Premiere in the cloud. So I can have a look at so I've mapped a share from within that the Qumulo cluster and connected my Z drive into it. And in that Z drive, I've got some rushes, and I've got some DaVinci Resolve directory and a Adobe Prem where I keep all the projects. And this is a project that I've got running in there already, which you can use obviously to do any edit work you want. And this is the other editor that I've got in there, which I've pre-built. So this one here is running DaVinci Resolve in the cloud, so I can use that application. I've also got some load running on the cluster, where I've got the Blackmagic test, and I'm firing off some performance hits on that Z drive as well, to give me some idea on, you know, what when we look at the analytics in the cloud, what that would look like. So this is the Qumulo dashboard itself. My machine's decided to play up. Right, so here we go. So this is the Qumulo cluster that I previously built, running just over a 3002 version. This is the dashboard, and I can see instantly some of the performance that those two editors that I built in the cloud are hitting on this cluster. And then the first thing I did when I built this out was to map a network drive to it. So the way that we've designed this the GUI is that you're always 2 clicks away from wherever you want, you know, what you actually want to achieve on it. So if I wanted to create an SMB share, here's the share I created that I mapped my drive to. So I'd create the share, give it a name, what the share name wants to be, create the directory, and I've got some options around here on SMB3 encryption and access-based enumeration, and then assigning share level permissions to that share. I could also, if I wanted to, would be to create an export as well to that exact same directory. Because I'm multi-protocol, I can access the same shares and files over NFS and SMB, so I could also create an export for that same directory. So back to the dashboard, I just wanted to show you some of the nice widgets that we've plugged into this GUI to make the usability from an administrator concern, you know, to be able to see things like where my load distribution is. So these analytics. So what we do in the file system, which is slightly different to our predecessors, is that we based our entire file system on B trees, and we virtualized the whole thing into 4K blocks. And what we do is we tag metadata in that file system. So we tag data about the data, but we also tag data about performance metrics as well. And that data is constantly being pushed into an internal file system. And then we sample that area to allow us to look at exactly what's going on in the file system. So this is what some of the uniques are in the file system that gives you this great visibility. And when we talk about real-time data analytics, it's about tagging that metadata and creating a file structure that's capable of being able to be searched and indexed in this way with these great analytics. So this shows me my read throughput and write throughput over the last couple of hours, my client load, what protocols they're running, and some ideas on capacity trending, etc., which are really, really useful and powerful for our administrators. So I can jump right into these analytics. I can click on the root of my file system, and in here I can see exactly what my hot clients and my hot paths are right now. So you can see the disk speed tests that I've got running from my 2 editors connecting to a directory on the Z drive, and you can see where the load is distributed here, and I can decide what it is I actually want to look at. I want to look at throughput information. We can see exactly where a lot of that throughput information is being hit in the file system in that directory, and what load that's made up of. So we're made up of about 50-50, 60-40 of read writes within that directory. I can click on that directory as well, and it will show me the clients as well that are accessing that particular directory. Or I can view it from a client perspective and say, okay, I've got these 2 clients that are connected, and what are they actually doing? What performance are they pulling on my file system? So very quickly I can easily tell where my performance is getting eaten up by on which clients. So as I say, very, very powerful. We've also got things like Capacity Explorer as well, and capacity trending. So what capacity trending will do is it will show us, some of the things that are very difficult when you look at a scale out file system that's, potentially petabytes in size is how to look at, what's happening with growth in that file system. So what this allows you to do is anything up to a year. It allows you to look at, what my file changes look like. And obviously this is a new cluster, so there's not really a lot I can show you on here. But typically what this would do is when clicking on our window segments, it would show us what data has been added and taken away from the cluster. So I can show you that on another window, on a dashboard, I think. I've got some VPN problems, so I can't show you that. So this is our analytics. We've got auditing, role-based access control, etc. And we also got the ability to look at the API from within the GUI as well, to look at what sort of API calls we can do on the file system, which all leads back to the automation of how we can build this out. We've got a lot of customers that actually build this out, or automate the complete build end to end with automation tools like Puppet, for example. So
Iain, where would people we do have customers who've developed stuff in the way of scripts and things, and how would customers get to those?
Yeah, so our entire API, as I say, is published out. You can go onto GitHub. We've got an area there in GitHub which gives you a ton of different scripts that you can use. We do have a lot of customers that tend to build out things like outside broadcasts, things like that, using, as I say, using products like Puppet, which allow you to automate that complete build, so it can hook into our API and and build this out end to end. So, I mean, that's as far as the build's concerned. That's as much as I wanted to cover in the short period that we've got. So to say, that's the how I built it out. This is the 4-node cluster in summary that I built out. Saw how quick it was to do that. And then this this Teradici client here is the second one that I built out as well. So it shows you how simple it is to build this out and get a working office up and running fairly quickly. So what I'm going to do now is I'm going to stop sharing my.
I was going to ask just one question now. How does it differ to AWS? AWS, because this is GCP, isn't it? So this is Google.
Yeah, so you can do. Yeah, you can do exactly the same thing in AWS as well. Slightly different with AWS is rather than just coming in here and searching the marketplace and picking it, I do think GCP is a little more simple to build. With AWS, you have to go into a CloudFormation, you pull down a CloudFormation template, build out a stack in AWS, which does exactly the same thing as this, and it's the actual process of building is just as quick. I do have a couple of videos out which I've posted out in LinkedIn which show you the build of AWS and GCP, but there's just slightly different tweak in actually building this out when you start off. One does it through CloudFormation templates, and this one just does it direct from the marketplace.
And if you were to try and scale this thing up, how would you scale the cluster?
Yeah, so we can scale this a node at a time. So we've got the ability of saying, okay, I want to add another node to this cluster, so I can make this into a 5-node cluster. We've also got the other option of coming into each of the nodes and actually increasing the performance of a node itself by changing the machine type in here. We'd have to stop one of the nodes at a time to do it, but the way that our erasure coding works, the cluster will still function with a node down. So we can actually scale this cluster while the cluster is still running and not impact the end users. So stopping each node, changing this machine type will give me more performance in a particular node. That way we're keeping the capacity the same and increasing the performance, or we can add more nodes to this cluster, as I say, 1 node at a time, and we can just keep scaling, and that will add capacity and performance to this cluster. So it just depends on what you want to do.
And if we want to sort of stop the cluster, does the data still remain?
Yeah, data still remains there. I mean, you can obviously, and what I tend to do with this environment here is I will just stop the cluster. The data remains where it is, and then when I need to demo the environment again, I can just easily start it back up again from within here. So very simple. So
Great.
I'll stop sharing my screen now and I'll hand it back to you, Ian.
Okay. Okay, hopefully that'll get me to the...
Okay, guys, well, no, thank you very much for that demonstration, Ian and Iain. I'm sure that gives us some insight into how easy it is to spin up a high performance file system in the cloud. And one of the advantages in doing that would be that for many remote working stations currently, the local bandwidth restrictions to domestic houses become an issue. So that's where Teradici can help. But also within a given facility, if you have a number of remote stations working concurrently, then the bandwidth of the facility becomes an issue. In which case, by moving the compute and indeed the storage to the cloud, then you have that removes that potential bandwidth bottleneck from that environment. And the other advantage being that you can spin these environments up as required. So it gives you the ability to not only work remotely, but also build a facility that's required for the job that you happen to be pitching for, and then tear it down again once that job's finished. And obviously you're only paying for those facilities while they're actually running. So there's lots of advantages to running Qumulo in the cloud. It's certainly probably the fastest growing up and coming file system globally, I'd say at the moment. It seems to be hitting the high numbers in all of the industry charts and industry groups that monitor these things. And if you want to know more, then we're obviously very happy to set up some one-to-one meetings with anyone who wants to have a more in-depth discussion, and very happy to do that remotely and set those meetings up. Just contact us. Following this webinar, we'll obviously provide a copy of the webinar so you can review it, and a copy of the slides. And obviously there's plenty of information both on Qumulo's website, on our website, and across the internet. So I wanted to mention our next webinar in the series of Round the Table from Global Distribution Presents. And the next webinar, which I think is in around 2 weeks' time, will be a more of an in-depth study for some of the customers who are currently using Qumulo. So there is a good number of major global media and entertainment brands, if I can express it like that have already deployed Qumulo in a kind of a pioneering way, and many of them are using Qumulo in the cloud and indeed on-prem to manage their services and the way they present those services to their customers. So people have been asking questions as we've been going through. So I'd just like to maybe answer one or two of those to everybody. So one question was, how do we get our data into the cloud? So there are a few ways of doing this, but perhaps one of the most straightforward and easiest way is to build another Qumulo cluster, but this time using hardware and placing that on-prem. One of the unique things about Qumulo is that it's actually the same code, it's the same file system. So all of your on-prem applications and things that you're running, managing your data with will work also in the cloud. But there's as part of the file system, there's a method of moving data seamlessly from your on-prem environment to the cloud. So that would be probably the most efficient way, would be a second Qumulo system on-prem, and then use that system to populate your on-cloud environment. I don't know, Iain, if you have any more input to that.
Iain, do you want to go on?
Yeah, sure. Yeah, exactly right. I mean, if we've got an inbuilt replication product called continuous replication, that's very efficient, the way that it moves data from Qumulo to Qumulo, doing snap-based replication. There are third-party tools you can use as well to be able to move data in and out. Also, if you're doing a small amount of data into each workstation, then you could connect using the RDP client. The RDP client allows you to link a folder on your machine to that on-premise environment and be able to move that data in. Obviously, if you do have bandwidth restrictions, then it's your ability to move data into the cloud is only as good as that the bandwidth is into the cloud. If you want to add anything, Iain.
Yeah, I mean, the bandwidth side of things is once you've done the initial sync, as I say, if you've got a video asset you're working on-prem and you want to get it into the cloud, you're working on it on-prem, it's in the background, it's copying over using our replication tool. If you change bits of it, we only send the change bits, so you don't have to resend the whole thing again. So it's a bit more bandwidth savvy, so it doesn't actually fill that up. I see another question on here about what other examples of customers using our technology. So this cloud technology is used both as a complete cloud environment, or some people use it as hybrid, both on-prem and in the cloud. We've got a number of different customers using with different things. I mean, one customer's using on-prem to do their video editing and creation, and then using the cloud for collaboration. So they have their directors, producers, and editors work on the asset in the cloud together, discussing it, going through it, so it speeds up the whole review cycle. We have other customers who are doing things like building complete broadcast infrastructures. So these are complete broadcast infrastructures that they spin up for a show that does everything, through editing, presenting, the whole 9 yards. So they've gone all in on this, and they can set up outside broadcast facilities simply by moving to a different zone within the cloud provider. Other customers are using this, so media services customers are using it as a mechanism to allow their customers to set up new workflows to do ingest, transcode, VFX, play out, whatever, and build those so they can basically build a channel very quickly to be able to air out to the cloud. So a lot of different people using it in different ways. Some people just do it very simply for a spin up some environment to use it as a backup for their on-prem production environment. So an on-prem production environment, and they want to put a cluster in the cloud as their DR copy. They spin it up, replicate to it, turn it off, and then and carry on again. So they use it as their sort of like a cloud DR. So there's lots of different ways people are doing that.
We've also got customers using for burst render as well, haven't we? And so they'll typically just use the capability of burst render in the cloud, because they know they can just build it as big as and quick as they need it to be able to fulfill a VFX workflow, and then they can replicate the finished jobs back down onto the on-premise cluster.
So I see a bit of a sales question here up. Who do Qumulo see as their competition in the M&E market space? Well, all the usual suspects are here. So you see people like Isilon, you see people like NetApp, and those sorts of people. We compete with them on a day-by-day basis, but I think what we're finding is that people just love the operational aspects of the systems, the way you can control and manage it. the agility to be able to move into the cloud as and when you want, to put it on, turn it off, tear it down as you wish, so you can control your costs. So that's it's the usual suspects, and so far we've been pretty successful in driving into a new market space.
Simplicity to scale as well is a big thing, because traditional systems that use RAID-based technology underlying typically take a while to be able to scale those systems, and they tend to be more complex when they're trying to scale.
Yeah. Okay, I think we're pretty well through the questions.
Yes, no, absolutely. So it just falls to me then to thank everybody for their time this morning and for joining us on this webinar. And I really appreciate you taking the time to do that. I hope it's been informative. I hope you can see how easy and how flexible Qumulo is for meeting the needs, especially the current needs for remote working and operating a performance file system in the cloud. So thank you very much for your time, and we'll all see you on the next one. Thank you.